Jamie, Nick, and now on to your next speaker, Krishna, who's going to talk about Data Lake, yeah, and Delta Lakes. And then afterwards, we'll have a 10-minute break before our final speaker of tonight. So welcome, Krishna.
Thank you, and hi, good evening, everyone. Before I begin my talk, I was, checking on his talk, and then, my talk is basically like a competitor. So he was talking about Iceberg, and I'm talking about Delta Lake. He was talking about Snowflake. I'm talking about Databricks. Disclaimer, I'm not being sponsored by them, right? Having said that, after seeing his talk, what I want to tell you is, he was talking about the how of Data Lake House. I'm going to talk more about the why. Yeah, so hopefully it's kind of complementary, and then you'll take away something interesting at the end of the talk. So with that said, hi again, I'm Krishna. Got about 15 odd years experience, worked with companies like Microsoft, Royal Mail, etc. Did a little bit of startup, as a co-founder. I'm also one of the authors of this book on Bitcoin. So if you are interested in anything related to Bitcoin, I'll give you a copy. I've got some. Outside work, huge Star Wars fan. Anybody in Star Wars geeks here? Yeah, all right, okay. So with that said, let's get started. Right, so today's agenda is we'll go about 50 years of the whole how the data warehouses revolution started. We'll just quickly take a 35,000 feet view of everything data, and then we'll come to where we are today, which is basically data lakehouse, which I think is very exciting to me personally. And then we'll also talk a little bit about the most popular architecture called medallion architecture. And if there's any other questions, I'll take that, right? Okay. Right, so evolution of data architecture, right? So the whole story starts in about 80s and 90s when a bunch of computer geeks, right? They've come up with how to run the world, with all the data that they're collecting, right? Like back then itself, they thought there's so much data. How do you manage this? How do you draw insights on that? And that's how the whole warehousing concept began, right? So in a typical data warehouse, it's kind of really simple. You have this structured data, something like an Excel sheet you dump in the SQL database, then you do a little bit of ETL, and then you have a structured data warehouse, right? Using that, you would do your thing, which is basically build a report or whatever. This worked well for good 30 years, right? So till 2010, till Google came about and then saw that, this is not working for us anymore because we just have so much more data now, right? Like Google itself is responsible for the big data, right? And then they came up with this whole Hadoop thing, and then they thought, okay, how do we, leverage that, right? So they came about the whole data lake concept. It's not just Google, obviously, but I'm just saying that for the sake of simplicity. So the big difference between these two guys is that, you're able to, is there a pointer? Oh yeah, okay, yeah, okay. So the big difference is, in case of the data warehouses, you just had structured data, right? Whereas in the data lake, you no longer have that limitation. So you can now store semi-structured data, unstructured data, binary data, which is basically your video, audio, et cetera, et cetera. Now, this ran well for good 10 years, and we are in 2020s now. And now there is suddenly this emergence of data lakehouse, right? So we're going to talk about that. Right. However, the blueprint is always the same, right? You don't want to change the blueprint because then you kill the functionality. Okay. The blueprint is data comes from various sources. Something happens, ETL happens or ELT happens, right? And then it gets stored somewhere. And finally, you draw some insights and reporting, BI, whatever. All of that blueprint is the same. There's no difference in any of the tools, what are you using? Because if you change the blueprint, you kill the use case. Right. Now, what are data warehouses good for, right? Data warehouses, believe it or not, are still the workhorse of the data world, right? You can't get away without them, right? You can't just stop them. No, they basically run 90% of your company's workloads, right? They're really good for analytics, storing really important stuff you want to store there, right? Okay. You want to do really important analytics because these been working for 30 years, right? Your CXOs are not going to jump onto data lakehouse just because you go and tell them it's better, cheaper, faster. It's not going to happen, right? So they're really good for analytical workloads. They're really good for, the reporting. So if you want anything to do with small data, they're really good, right? The problem, what is the problem? The problem is nobody knows what's happening under, right? Like if you're talking about Informatica or any of the other data warehouses, you don't know what's the format inside, right? It's just like a secret sauce that they have a monopoly on, right? So basically that's one big problem. The second thing is, largely speaking, they support SQL only, right? So they don't support, anything you want. Also no out-of-the-box support for streaming. The reason was, the world was built for batch data, right? Guess why it takes 3 days when you send the money or anything like that, right? Because there is a batch job that happens at the end of the day, and then something happens tomorrow, right? And then if there's a weekend, it takes like 2 more days, etc., right? This is the old world, right? And the worst part is, this is more like an interview question. So the worst part is storage and compute are coupled tightly. Okay, what do we mean by that? What we mean by that is, let's say you want to run a bigger analytics job, right? You want more CPU, but then you couldn't get it because as part of the licensing, you have to buy one more server, right? Even though you don't need the extra memory, you just wanted extra CPU. You couldn't get it, right? That's called compute and storage. They're coupled, right? That's one big problem. Data lakes obviously solved some of those problems, right? And that way they're so popular. And then, people made a lot of money, doing this for like 10 years, etc. The main advantage of data lake is that it is for the first time, it has offered this. There are other streaming solutions, but it is offered in a more elegant way. Solutions for streaming, cloud data, IoT, big data processing, and more importantly, the decoupling of storage and compute. That was a big thing because you could now just store pretty much petabytes of data and then run analytics on it as you want it and shut down the CPU. If you don't want it, just have the data, right? That was possible. And that's like, basically they were able to support the 3 Vs out of the box, right? The variety, the velocity, and the volumes. These are the famous 3 Vs, right? So that's your typical, architecture of your data lake, right? This is a typical data lake architecture. Unstructured data, all types of data. Then you have the data lake, you run an ATL, et cetera, and then you get all this, nice little functionality. One thing missing in data lake is veracity. Okay, what do we mean by veracity? Obviously, truthfulness, right? That's a literal meaning, but essentially, because you just dump the data, you don't know what's happening after a while because somebody might change the schema upstream and then downstream things are breaking, etc. So there's no longer confidence in what is happening underneath the hood. And then the data warehouses guys were like, yeah, gotcha. Look at this. You thought you could, get away with us, right? But then now you are coming back to us, right? So that's the kind of thing that was happening, right? There's no veracity in data lake, right? Right. Anyway, before we go, obviously there are a lot of pros of data lake, which we already kind of discussed, right? So it is offered that flexibility in terms of storage and compute. That's one big thing I would say. There are a lot of stopgap solutions that people have developed over the last 10 years that have solved some of the problems, like the schema evolution problem. You can use Hive catalog that kind of solves the problem to some extent, right? So that's what was working. And then people were kind of okay with it, but they were not putting the critical workloads. They were putting kind of like the subcritical workloads sort of thing, where big data analytics is necessary, right? The biggest thing is obviously cost effectiveness. You could run this on a commodity machine. You don't need like a IBM mainframe, which is running on diesel sort of thing, right? You don't need that. So basically the cost effectiveness was a big thing for data lake. The challenges, however, obviously, with everything, you come to a new technology, there'll be some challenges. The biggest challenge is, I don't know how many of you worked as big data developers using Hadoop, right? It's just like so messy. Everything is complicated. There's like 50 tools for one thing. So you have to learn all of those different things and figure out. So it was good for contractors. You could make a lot of money, but things were really slow if you were using Hadoop and all of that, right? Apart from that, the whole turnaround means a simple analytics job that could finish on data lakehouse in, let's say, 3 months. It would take like 3 years on this system, right? That was one big problem. There's also this small file problem, which we'll discuss probably later. There's no transaction guarantee, right? That's one big thing. I think he briefly touched about ACID. There's no such thing on data lake. That was the biggest reason why data lakehouse has been developed, right? Right. So quickly comparing the differences, like I think we talked about this already, but essentially, data lakehouse is something that you can dump a lot of unstructured data, and then still be sure that it's sitting there. You could come back, you could maybe build a catalog, and then use it later. So that was a big advantage when it comes to data lake. But anyway, let's move on. Sorry. Okay. So now we are in the world of data lakehouse, right? If you see in this picture, and then let's say the picture before, just give me a second. Yeah. So there's hardly any difference, okay? So there's not a lot of difference. There's still the same thing. The only difference is that in case of data lakehouse, there's a metadata sitting on top of your regular data. So that metadata is now able to do the magic. That's the secret sauce, right? That's what these guys are fighting for. Like, Iceberg and Delta Lake and all of these guys, they're basically working on that part. They're working on the metadata part so that, you can now support ACID to some extent, yeah? Otherwise, it's the same thing. The blueprint is always the same, right? So you have data coming in, you could do both batch and streaming, and then there's a storage layer, there's a metadata layer on top, and then you have your APIs for running your SQL jobs. Or the good thing here is you have data frame APIs also, which means you could use Spark and PySpark and all of that, right? And then at the end of it, you get your final consumption layer is your BI reporting, et cetera, et cetera. Right, so quickly talking about the benefits of data lakehouse. The benefits are, since you have the metadata layer, you now have out-of-the-box support for ACID transactions, which means you could be reasonably confident that if you do a SQL query, let's say some sort of DML, you could be reasonably confident that it will process. Even if it fails in between, there is some sort of guarantee because of the way the metadata and logging works, right? You could have some sort of guarantee that, okay, it will work eventually, right? There's an eventual consistency concept, et cetera. And these guys have done it beautifully using logging, which we'll talk sooner. They've done it beautifully so that even if the transaction fails, you would actually just by checking the logs, you can get the right state of the transaction, which I think is that's the secret sauce, obviously. So because of that, you now have, for the first time, the best of both worlds, right? You have cheap storage thanks to cloud, and then you have the separation of cloud and compute, right? And then you also have ACID. Essentially, it basically, in my opinion, takes away the need for data warehouses, largely speaking, right? So that's the big revolution. People talk of LLMs and AI revolution. I think this is probably somewhere there, right? So it's somewhere there in terms of the revolutionary nature of the technology, because this is something you could learn and, in 5 years down the line, you're going to use it for sure. Whereas with the LLMs, it's kind of hazy all over. But I would say this is definitely something very interesting. Again, this architecture has been proposed by Databricks, right? And the way they see things is that the same blueprint is still there, except this time around, there is a concept delta format, right? And then you have a multi-tier architecture wherein you have the bronze, you have the silver, and the gold. And then that's how you do your jobs. And then that gives you the confidence that, things, even if they break or you mess up or something happens, you could always roll back to your bronze layer, etc. And then that's the recommended architecture that like the basic bare bones architecture recommended by Databricks. To summarize it, right, you have a cloud storage, something like this. This sits on a cloud storage, S3 or ADLS, and uses Apache Parquet format, and then enables ACID transactions, and also offers cloud native features like CDC, autoloader, time travel, caching, and my favorite is schema evolution and merging as a result, right? So essentially by using the metadata, you're getting all these additional features which weren't there before. And then because it sits on cloud, there are certain cloud native features like autoloader, right? So it's actually better than data warehouse because that's not possible in warehouse, right? You have autoloader, which is a technology that can basically run millions of files. So if you can dump millions of files, the transaction would still go through. So essentially, it's that. The summary is that, but just by combining these kind of like Lego pieces, you're getting this beautiful end result. Okay, now let's talk briefly about what Delta Lake is, right? So Delta Lake, as I started off, it is kind of a competitor to IceSpec format. So this is a big rivalry between these guys. So, they don't see face to face. And then, there's, like I said, if you're looking at Snowflake, they're working with AWS, whereas these guys are working with Azure and Microsoft. So there is a lot of, hidden rivalry between these guys. But I would say they're roughly doing the same thing, right? After all, they understand that this is what you need to do, and then they're kind of doing the same thing. Except I would say, I think that Delta Lake is slightly more advanced and more, user-friendly. Sorry, in the evolution curve. So working with Delta Lake feels super cool, right? There's no confusion about what happens. It'll just do everything for you, provided you're working on one of the clouds like Azure. So it's really easy that way. So there's no confusion. The learning curve is really simple. Right. How does it work under the hood, right? What is the magic? The magic is basically, you got a Parquet file, which is a read-only file, right? It stores your transaction log data there. And then let's say you've done a transaction, you inserted something or you modified something. It'll create one more Parquet file, read the old Parquet file, apply the transaction, create a new Parquet file, right? That information is stored in the JSON. So the JSON is the metadata there. So for every transaction, a new JSON file is created, right? And at every 10th transaction, there is a checkpoint that is created. So what is happening is, if you want the current state of the database, it just simply goes, looks at the Parquet files, looks at the JSON files, and then figures out, okay, it basically figures out the current version of the data table, right? Really simple, in my opinion. I mean, I could understand that in like, I don't know, 2-3 hours, right? So it's you guys understand already. So it's actually a really simple concept. Just by having a bunch of JSON files with transactions, and then a Parquet file, which is basically like a state of transaction and a read-only file format. So you're basically combining that, and then you're getting the current state. Now, like we discussed previously, what happens if a transaction fails in the middle? Like, how do you get the ACID there? If it fails, you just simply go back to the previous JSON. You didn't commit the new JSON, just go back to the previous JSON. So you at least have something to know that, okay, it failed somewhere, right? So that's the kind of the beauty of how these guys came about. Obviously, the real architecture is obviously very complicated. I don't know that myself. So, you'll have to read up a lot of blogs to understand the whole full architecture. But this is the high level architecture of how it works. Right. And by having that simple concept of combining the JSON files and transaction logs and the Parquet files, you're getting all of these beautiful features, right? We already talked about a lot of them: time travel, scalable metadata, unified batch and streaming, DML operations. So all of these cool things are coming to you out of the box, right? You no longer have to, pay those expensive licensing fees for Informatica, SQL servers, and all of that, right? So you're getting all of that. Just to be clear, there are some gotchas which we'll talk in the end, but then this is really good because this is so cheap, so fast, so effective, and all of that happens like magic, right? However, we saw the JSON files, right? What happens if you have like 100 transactions or 1,000 transactions? Obviously, they pile up, right? You don't want that. So there are things like you could do something called compaction that removes all the unused files. So like the pointers is pointing to the new ones, etc. There's something called Z ordering, which basically enables even faster transactions if you want to do that. Partitioning, we all know how it works. There's something called liquid clustering. So all of these are optimizations in Delta Lake, basically that enable you to run your queries faster and faster. So the goal of this whole Delta Lake thing is how do you run the query faster, right? And cheaper and more effectively. And there are obviously various ways of doing that. Partitioning is one such way, Z ordering is one such way, liquid clustering another way. But obviously there's something called photon acceleration. Spark guys have come up with something called photon acceleration, which is even faster. So there's always something new in that world, right, obviously. But then it's really something that's going in the right direction, in my opinion. Having said that, okay, let's quickly talk about the cloud native feature. These are some features that happen because they're on the cloud, right? You couldn't have them in your normal SQL, servers, right? The reason is that some of these features are developed by the cloud infrastructure providers like Azure or AWS. We all know what file notification is, right? And we have like event-based triggers based on that files. For example, you have an S3 bucket. Somebody drops a file, and then you get a notification. Using that notification, you could trigger some other job, right? That's basically file notification, right? Using that, these guys are able to kind of run this whole data, table updates, basically transaction updates, right? So they've combined that with this, and then now they claim the ability to process millions of files, per second sort of thing. That's the kind of transaction throughput you could have, and that's mind blowing because, that means it pretty much solves most of the real world problems, real world transaction problems, basically. There's something called merge. Merge is a very complicated, obviously, transaction in the data world, in the DML world. They're able to do that. That's the beauty. That's the power. They're able to do merge without breaking the whole thing up, and they're able to do merge by some clever architectures under the hood, right? Using that, they're able to do that. Essentially, what I'm trying to say is, whatever data manipulation language commands and data definition language commands we had in the good old SQL, they're pretty much able to cover most of it or all of it, right? There's probably a few things that not there, but then they're kind of getting there. There's something called change data capture. So essentially, let's say, you have a database, you're watching, and then something happens, somebody writes a transaction on the database, you're able to capture that particular change and replicate it in your cloud database, right? That's called change data capture. There are some use cases why people want that, but they have a special function for doing that. That's also very interesting to me. Right now, the one thing that was missing, if we go back to the data lake world, right? Data gets messy, right? And the reason is people are dumping data. There's no clarity on who should do what, and how do we track back if something breaks, etc. Right? That's called data governance, which is actually very, very important. So Delta Lake guys in Databricks have come up with something called Unity Catalog, which has basically replaced your Hive catalog. Using that, they're able to give you the data governance features. So for example, you could say, hey, this person, an analyst, could only see this particular table, right? And he can only do the reading, right? Whereas that person, Sarah, she can actually write as well, right? So that sort of granular permissions you're able to give with the help of Unity Catalog. Now, obviously, the cloud providers like Azure, they have something called Purview, which is more sophisticated. There are many other providers, but essentially, we have a hat in the race with this. Yeah, previously we were talking about medallion architecture. How many of you have heard of this medallion architecture? All right, okay, so a lot of you. So I'll briefly explain what it is, and you'll understand why it's becomes the popular one, right? So essentially, there are 3 layers in the medallion architecture. So you have the bronze, you have the silver, and you have the gold, right? Now in bronze layer, what we are doing is effectively not doing anything. So we are just taking the data, right? You have the extract, you're extracting, and then you're loading it. So it's an EL instead of ELT or what ETL, right? So you're basically keeping the data as is in the bronze layer. After that, and the reason why you want to do that is, let's just say you messed up something, some transaction, how are you going to go back, right? So the bronze layer is acts as like that raw data source, which you can always refer to in case something happens downstream, right? So that's why you have simple raw layer. In the second layer, it's called silver. In the silver layer, what you do is you pull more data, you clean the data, and then you make sure it is ready for consumption. So it's kind of like you're preparing the data, right? You're saying, okay, maybe I want to get data from some other data source. I want to clean all the data errors, etc. I want to make sure there's quality in data. So by doing that, it becomes consumption ready. But it's not actually ready for business usage yet, but it is consumption ready. The third layer is basically the final layer, is where it's business friendly, right? So you have aggregated tables and aggregated columns. Whatever the business guys want, you're basically able to do that. That's the consumption layer, final consumption layer. So by doing this 3-tiered processing, what is happening is you're getting the best of the both worlds, right? I mean, best of all scenarios, not both worlds, sorry. In case you mess up something, you can always go back to the previous one, and then you already have a cleaned data quality, correct state as well if you want to do something else. And then the third layer is optimized for your dashboarding and all of these things. So it's optimized for querying basically. You can really query fast, get the results fast, that sort of thing. And shout out to DBT, and I think it's basically one of those new paradigm shifts in the data world, right? I think it's just going to become like the GitHub for software developers. So DBT is going to just take over the whole transformation business. So you can use something like DBT for doing those transformations, and you can achieve the required states if you want to. And it's a really beautiful tech piece of, I would say it's more of philosophy rather than technology. So the way you want to do data transformations, they've defined everything beautifully so that you can't mess up. Just follow the philosophy and the guideline, you're going to get it right. So that's the whole kind of like how things happen, right? So, and the reason why things happen the way they happen. So, and underneath you have the storage layers, Hadoop, S3, whatever. On the right, you have the analytics layer, the engines, Spark, Presto, Trino, whatever, right? So it's a plug and play architecture, and you could replace one of the pieces if you want to do that. And you have that flexibility of doing that thanks to this architecture. So yeah, apart from the previous ones, we have a bunch more of these query engines if you want to do that. Honestly, some of them are kind of old, so people don't use that anymore. But but still, you could use that, right? That's the beauty of it. So you can use something like Redis and Cassandra, whatever, if you want to do that, and they work seamlessly with the Delta Lake architecture. There's something called Delta sharing. I'll wrap this up, but basically these are some additional features. Just wanted to let you know, guys. So it basically a way of sharing protocol instead of copy paste and email and all that, right? So they create like a web token, and then there's an expiry. It's like borrowing a little bit from the the software development standards. So it gives you that flexibility that, okay, the person gets the token and then it expires in some time, etc. This is a very interesting feature. You're probably not going to do any programming on that, but it's something good to know. Yeah, the final thing is something called data connectors, which is a way of connecting those engines to your data lake, right? So it's not just Spark, it's not just Flink. You have all of these other things that you can connect with, and using something called Delta Connector. So your basically Delta Lake is now any engine friendly, that sort of thing, right? Becomes like a foundational piece of your architecture. That's pretty much it. So anyway, the gotchas, we didn't cover these things, right? So if you're really building if you want to really build a full-scale data architecture, it's not just enough for you to have Delta Lake, etc. These are the other things that you need to understand to come up with. We work with government, and a lot of times they're not even bothered about what is the architecture you use, right? They don't care about that. They usually care, they're more worried about what is your data governance policy? What's your master data management? How is it looking, right? And what's your data cataloging solution? They're worried about that bit more than how fast is your processing engine, right? They don't care about that much. There are solutions to this. In fact, I would say the way master data management works and the way data governance works is very complicated. There are no clean solutions for that. We have a clean solution for processing, but we don't have clean solutions for that. There's a lot of competitors, obviously, because of that. But it's an evolving space. I would recommend you kind of spend some time and learn a little more about these things. Hopefully, we'll do a talk in the future. But then these things are somewhat important. I thought you guys should let know. That's pretty much it. So we learned about a lot of things today: data warehouses, data lakes, and medallion architecture. Hopefully, my next talk I'm planning to do on DBT. So yeah, that's pretty much it.
Thank you, Krishna. Any questions?
Well, thank you for the talk. I actually have two questions, if that's okay. One of them is, in the medallion architecture, would it make sense to, in the gold layer, to have a star schema? And the second question, I don't know if you want to answer that one first.
Okay, that's a very interesting question. It would, yeah. Sorry. Okay, so goal layer is basically an aggregated layer, right? So you want to have really concise tables over there. You don't want to do any other joins in that layer. So it's basically should be consumption ready, right? So essentially you plug in something like a Power BI and then you want to consume it right away. So I would say, I might be wrong, but I would say that you don't want to have any other complication there, right? Your star schemas, etc., you want to have them probably in the raw layer, right? So that, sorry, in the silver layer, probably, right? So it's ready for joining. Yeah. So I would say don't do it in the gold layer, probably in the silver layer. Does that answer your question?
Yes, thank you. The second question that I had was in regards to streaming. Given the nature of pretty much all the data lakehouse solutions, which end up being Parquet files, doesn't the streaming ends up being more handled as micro batching?
Okay, so streaming by itself is a very complicated and evolving topic, right? So in Spark, there's something called Spark structured streaming, right? And as of now, the production ready version only supports micro batching, but they're trying to get rid of that. They're saying we can do real time, right? So I don't think it's production ready. So I would say if you want to do non-micro batch and really real-time streaming, you have to go with something like Kafka, right? But 90% of the use cases, your micro batching should work because it's battle tested already and it'll work to that micro batch level. Yeah.
Thank you.
Thank you.
Thank you. Any other questions?
Yeah, I often come over that Databricks is kind of being put in front of me, and it seems to be very popular. And also, on the other hand, I feel it has a lot of, like, it locks in, like, I don't have control over the infrastructure, it's hard to manage the version. And basically what, like, let's say, as a data engineer, what I'm interested about is that make all the data available and accessible to all the consumers, whether it's internal or external. And there are a few other competing services like BigQuery and Snowflake, etc. And let's say whatever is in between, we say Databricks is solving that. So they have the metadata layer, the medallion processes, and like PySpark. But are there other solutions or yeah, other solutions out there which would be comparative to Databricks?
Right? That's a long question. So I'm just going to repeat the question and summarize that. Okay, so what he's asking is, basically, is Databricks the go-to solution for your most of the use cases, or do you have something else, right? I would say, unless you're working in like a financial bank like Wise, and then your boss says you have to get to the bottom of everything and then make sure you only code and don't use any cloud apps, right? So 90% of the time, you can stick with Databricks. I would say it works seamlessly, right? So much so that Microsoft are copied Databricks and they've come up with this Fabric thing, right? Which is basically a competitor to that, right? Which shows that, yes, that does work. Now, there are certain edge cases, or like you say, vendor lock-in, if you want to avoid that, right? You might say, okay, I want to do something else. But technically speaking, they are open source. Delta Lake is an open source format, so you don't have the vendor lock-in. You probably have some amount of vendor lock-in if you're using their own product, but then you will always have the flexibility to choose something else. Let's say, for example, you want to use BigQuery, you can use BigQuery, and then they'll probably connect with Delta Lake, right? So you don't have the vendor lock-in. You could say that, yeah.
Okay, thank you. We'll have a 10-minute break now before our final speaker of this evening, who's going to be Andre, talking about data.